Hello, welcome to the Matlab video series, Chapter 3, Mathematical Operations on Arrays. Matlab is designed to carry out various advanced array operations that have many applications in science and engineering. This chapter presents the basic, most important mathematical operations that Matlab performs using arrays. The first operation is the addition. As you can see here, you have two matrices A and B. They're of size 2 by 3 each, so we can add them. The adding happens when the elements in the respective positions are added up. Similarly, for subtraction as well. This is an example for finding the sum and difference of two vectors, VA and VB. So we define VA and VB and find the sum using VA plus VB, or the difference, which is VA minus VB. So the elements in the same positions gets added or subtracted. This is another example where we have two vectors. Vector A is added to vector B, and here is an example where A and B are two matrices. They have the same size, so we are trying to subtract the elements. We get -5, which is 5 minus 10. Then -10 is -3 minus 7. 4 is 8 minus 4. Similarly for the other elements. But if you try to add a vector A to the matrix A, you get the error saying matrix dimensions must agree. When a scalar, that is a number, is added to or subtracted from an array, the scalar is added to or subtracted from all the elements of the array. This is an example where you have a vector, you're adding the number 4 or the scalar, so all the elements are added to the number 4. Similarly, here there is a matrix and you're subtracting 5 from every element. Next we come to array multiplication. We use the symbol asterisk for executing multiplications in Matlab, but it should follow the rules of linear algebra. If A and B are two matrices, the operation A multiplied with B can be carried out only if the number of columns in A is equal to the number of rows in matrix B. So the result is a matrix with the same number of rows as A and the same number of columns as B. We consider two matrices, A and B. We notice that they have the same number of rows for B as the number of columns for A. So we can get the product matrix C, which is of order 4 by 2. Here is an example of how the matrix multiplication occurs. First of all, you have to check if the sizes are matching. So here the number of columns in A is 3 and number of rows in B is 3. So you can multiply A with B. Every row is multiplied with every element in column B. So 1 times 2 plus 2 times 4 plus 3 times 1. We get the first element in the product matrix C. To get the next element, 1 times 3 plus 2 times 8 plus 3 times 2. And the third element, 1 times 2 plus 2 times 3 plus 3 times 5. Similarly, for the next row, 3, 4, 5 is multiplied with every element in each column of B. The same operation for the next two rows as well, and you get the product matrix C. In Matlab, we define A and B as two matrices and we multiply A with B. Of course, after checking if the number of columns in A is equal to the number of rows in B. But if we try to multiply B with A, we get the error, that is, inner matrix dimensions must agree. This is an example where F and G are two square matrices and they have the same size as well. So it is possible to multiply F with G, and also we can multiply G with F according to the rules of linear algebra, but the product matrices H and I are different. So the product of the multiplication of two square matrices, which are of the same size, is also a square matrix of the same size. But multiplication of matrices is not commutative, which implies A multiplied with B is not equal to B multiplied with A. Next operation is the power operation. A raised to 3. So here the matrix A is multiplied with another matrix A, and that product matrix is multiplied with one more A. So A times A times A. You see the answers for both the commands, A raised to 3 or A times A are both the same. Now note that A is a square matrix. Here we have H, which is not a square matrix. So if we try to do H raised to 2, we get matrix must be square. This is because it does not agree with the rules of linear algebra. Similarly, if we try to multiply H with A, we cannot, because inner matrix dimensions must agree. Identity matrix. We have already seen identity matrix in Chapter 2. It is a square matrix in which the diagonal elements are 1s and the rest of the elements are 0s. It can be created using the I command. When an identity matrix multiplies another matrix or vector, that matrix is unchanged. If the matrix is a square, it can be multiplied with identity matrix from the left or right, as illustrated in this example. The inverse of a matrix. The matrix B is the inverse of matrix A if, when the two matrices are multiplied, the product is the identity matrix. Both matrices must be square and the multiplication order can be BA or AB. Both will give the identity matrix as the result. So B is the inverse of A and A is the inverse of B. Here is an example for the same. Now, the inverse of a matrix is written as A to the negative 1. In Matlab, inverse can be obtained by raising A to the power negative 1 or with the inv function, inv of A. We have A, which is a square matrix, and we know the inverse exists. So we find it using inv command. When we multiply A with B, we get the identity matrix. Here is another example. A is multiplied with the inverse of A. We get the identity matrix here. Not every matrix has an inverse. A matrix has an inverse only if it is square and its determinant is not equal to 0. So what is a determinant? A determinant is a function that associates with every square matrix a number called the determinant of the matrix. It is typically denoted as det of A or determinant of A. It is calculated according to specific rules. For a second order 2 by 2 matrix, the rule is A11 multiplied with A22 minus A21 multiplied with A12. Matlab has two types of division, the right division and the left division. The left division, how it is used to solve the matrix equation A times x equal b, where x and b are column vectors. Now the equation can be solved as follows. You multiply with A inverse on both sides. You get I times x equals A inverse b, which is x is equal to A left division b. The left division method is more accurate for solving a set of linear equations, as the calculation of inverse is less accurate for large matrices. The right division, it is used to solve matrix equation x times c equals d, where x and d are row vectors. The equation can be solved as follows. You multiply with c inverse on both sides. So we get x times I equal d times c inverse. So that is x equal d right division c. We have a system of linear equations here in three variables. So we can do this using either the left division or the right division method. Let's look at the left division method first. The A, which is the coefficient matrix for the left division method, is 4, -2, 6. Then next row 2, 8, 2, and the last row 6, 10, and 3. Now the x and the b are column vectors. So the b is 8, 4, 0 as a column. The next method is the right division method, where x and d are row vectors. And what about c? C is written in the following way. You have 4, 2, 6. That is the coefficients of all the x in the first row. Then -2, 8, 10. Coefficient of all the y's in the second row. And 6, 2, 3, which are the coefficients of z in the third row. Element by element operations. Operations are carried out on each element of the array. Now, addition and subtraction are by definition element by element operations, since when two arrays are added or subtracted, the operations are executed with the elements that are in the same position in the arrays. Element by element multiplication, division, and exponentiation is entered in Matlab by typing a period in front of the arithmetic operator. We have A and B, which are two matrices. They have the same size, 2 by 3. A dot star B implies every element in the respective positions get multiplied. C equal A dot right division B. So 2 is divided by 1, 6 divided by 4, 3 with 10, and similarly for the remaining. B dot raised to 3 implies every element in B is raised to 3. So 1 cubed, 4 cubed, which is 64, 10 cubed, 1000. Similarly for the next row. Can we multiply A with B? No, because the number of columns in A, which is 3, is not equal to the number of rows in B. What is the application for element by element operations? It's useful for calculating the value of a function at many values of its argument. How is it done? By first defining the vector that contains values of the independent variable, then using this vector in element by element operations. X is a vector going from 1 to 8, and we want to calculate the different values of y. So we use the period before the exponentiation, and here we are not using 1 because it is just a scalar multiplied with a vector. So we get as many values of y as the number of x. Now the example where z has the following values, and you use y with z cubed plus 5z dot division 4 times z dot raised to 2 minus 10. So notice that we put a period before the exponentiation, then the division, and here we are not putting the dot before the multiplication because we are dealing with just a scalar and a vector. So we get as many values of y's as the number of values for z. Using arrays in Matlab built-in math functions. Here is an example where x is going from 0 with increments of pi over 6 to pi. Another example where we use the built-in function cosine. So cos of x. Every element is taken into account and you get the values for y. We can use the built-in function for matrices as well, as in the next example. This is a list of functions that are useful for handling arrays. You have mean. Mean of a gives you the mean value. Max of a gives you the maximum value in a vector. dn in square brackets gives you the maximum value and the position where it lies. Similarly, for the minimum function, min of a, sum of a gives you sum of all the elements in a vector. Sort a arranges it in the increasing order. Median gives you the median of a vector. Standard deviation is for finding the standard deviation, so STD. DET for finding the determinant. Dot for finding the dot product of two vectors, so DOT of a comma b. Cross of a, b, you get the cross product of two vectors. Now the two vectors must have 3 elements for using the cross function. Inverse INV, which can be used as here, INV of a. Random numbers. Generation of random numbers. Simulations of many physical processes and engineering applications frequently require using a number or a set of numbers with a random value. Matlab has 3 commands, rand, randn, and randi, that can be used to assign random numbers to variables. The rand command. The rand command generates uniformly distributed random numbers with values between 0 and 1. The command can be used to assign these numbers to a scalar, a vector, or a matrix. Rand generates a single random number between 0 and 1. Rand of 1, n generates an n element row vector of random numbers between 0 and 1. So rand 1, 4. It generates a row vector with 4 elements. Rand of n generates a square matrix of order n. Rand m by n generates a matrix of order m by n, as in this example 2 by 4. Rand perm of n generates a row vector with n elements that are random permutation of integers 1 through n. So rand perm of 8 gives you a random permutation every time you run that from elements from 1 to 8. The randi command generates uniformly distributed random integer. The command can be used to assign these numbers to a scalar, a vector, or a matrix as shown in table 3.3. Randi of Imax, where Imax is an integer, so randi of 15 generates a single random number between 1 and Imax. Randi of Imax, n, so we have randi of 15, 3 generates a square matrix of order 3 with elements from 1 to 15. Randi of Imax, m, n generates an m by n matrix with random integers between 1 and Imax. So we have 2 by 4 matrix with elements from 1 to 15, any of them. So each time you run this command, you will get a different random integer matrix. The range of the random integers can be set to be between any two integers by typing in square brackets Imin, Imax instead of Imax. For example, a 3 by 4 matrix with random integers between 50 and 90 is created as follows. So in square brackets you put 50, 90 and then the size of the matrix you want, 3, 4. Next we come to rand-n. Rand-n command generates normally distributed numbers. So as the n indicates, it generates a normally distributed set of numbers with mean 0 and standard deviation of 1. The command can be used to generate a single number, a vector, or a matrix in the same way as the rand command. For example, a 3 by 4 matrix is created as rand-n 3, 4. This is an example where you're calculating the coefficient of friction mu. A table is generated for the experimental values. 6 tests are conducted. You have the mass in kilogram and the force. So you express the mass as a vector, then the force is another vector, and we know the relation mu equals F over mg. So g is a constant, define that as well. G is 9.81. Mu is calculated as F dot division m times g, because F is a vector and m is also a vector. So we get 6 different values for the coefficient of friction. If you want to find the mean, you apply mean of mu and you get the average value. Let's work on some questions from your textbook. X equal 1 to 7. So for question 1, we have x going from 1 to 7 and y is given as the following expression. So you put that in with the dot before the multiplication and exponentiation as well as the division. So the first operation is always for the brackets. This will be executed. Then other functions, which is the exponentiation, and later division, multiplication as per the order. It goes from left to right. So here multiplication and last the division. So if we run this, we get the 7 different values for y. Question 2. Define the vector v. It goes from 5, 3 to 1. So we have 5, decrement of -1 till 1. Then use the vector in a mathematical expression to create the following vectors. So part A, let's call A equals, how do you use this vector? Its name is v and each element is raised to 2. Part B, the vector B equals v raised to every element in B in V again. So V dot raised to V. C. So C equals 25, 20, 15, 10, 5. So you multiply with 5. So V times 5. And part D. D equals 43210. So every element is less than the element in V by 1. So it will be V minus 1. Let's run this. Okay. Next question. Let's work on question number 3. The area of the parallelogram shown can be calculated by length of RAB cross RAC. Use the following steps in a script file to calculate the area. Define the positions of points A, B, and C as vectors. So let's define A is 2, 0, 0. Because we have a cross operation and we know to use the cross function, the vectors must have 3 elements. B is 10, 3, 0. And C is 4, 6, 0. RAB would be B minus A. And RAC would be C minus A. Now to find the area, first of all we have to find the cross product. So cross of RAB, comma RAC. And then the length of this vector. So we can use the norm command. Norm of this, which will give you the magnitude 42. So the area is 42. We can also use this sum and square root command to find the magnitude. Let's see how to work on that. So you find the cross product first. B cross RAC. Now we need to find the square of every element here. So let's call it as area underscore 2 dot raised to, and then the sum of all the elements in that vector. So if you run this, you get the square of every element. Then find a sum using sum command, and finally the square root. So you get the same answer for both. Question 4 is about limits. Show that the limit x tends to 1 for this function is equal to 2. So we have x values 5, 3, 2, 1.5, 1.1, 1.001, 1.00001. We have to use format long to display the answers. Let's write the expression for y. So it will be x dot square minus 1 dot divided by x minus 1. Run this. So we see that as the x value tends to 1 or approaches 1, the y values approaches 2. So we can make the comment there, as x approaches 1, y approaches 2. So that is the limit. Question 5. Use Matlab to show that sum of the infinite series is equal to pi. Do this by computing the sum for n equals 10, n equals 20, and n equals 50. We'll just do for part A, and you can repeat the same for part B. For each part, create a vector n in which the first element is 0, increment is 1, and last is 10, 50, or 100. So here we have 10 for the first part. Then use element by element calculation to create a vector in which the elements are given by this term. So let's see, it's going to be -3 dot raised to -n dot divided by 2 times n plus 1. So here we get 11 elements for v. Now we need to find the sum of all these elements, so we can use the sum command and later multiply this with square root of 12. So let's run this, get the value as 3.1415, etc. So the value is corrected to 15 decimal places because of format long, and it is the value pi. So if you try the same for part B, all you need to do is change the value of n. This time it will be 20, and you can run this. You get the same value, pi. So you can make a comment. The series converge to pi. Question number 6. Create a 4 by 4 matrix having random integer values between 1 and 10. So let's call it as A, random integer, so rand I, between 1 and 10. So we can just say 10, comma, the order should be 4 by 4, so it's a square matrix. It uses elements from 1 to 10. Use Matlab to perform these operations. Part A is multiplied with A. Is it possible? Yes, first of all it is a square matrix, so you can multiply A with A. And also it follows the rules of linear algebra, which is the number of columns in A is 4 and the number of rows in another A is also 4. Part B, A dot star A. This is element by element operations, so you can make a comment. Because A and A are both the same size, so you can do element by element operations. Part C, A left division A. If we run this, we get the identity matrix of order 4. Because A left division A is equivalent to inverse of A multiplied with A. Part D, A dot left division A. So every element in A is divided with the other element in A itself. You get all ones. E, determinant of A, which is using det command, and we know determinant exists only for square matrices. Part F, to find the inverse, so you can find it using inv function, and that's the inverse, which is a square matrix again. Now question 7 is about solving a system of equations. So we have the coefficient matrix A, which will be 3, -2, 5. Next row, -4.5, 2, 3. And the last row, 5, 1, -2.5. We have the constant matrix, which is B equals 7.5, semicolon 5.5, semicolon 4.5. We'll be using the left division method, so B should be a column vector. Now X will be A left division B. Or you can also calculate it as inverse of A multiplied with B. But the left division method is more accurate, as calculation of inverse is not accurate for big matrices. So preferably use the left division method. That's all for now. Thank you.